Okay, welcome to Data Structures and Algorithm. We will discuss hash tables. No? Course learning outcomes. 1, we have to familiarize the use of hash tables. 2, learn how to use a good hash functions. 3, learn the simple hash table in operation. Okay, so we will be defining first the meaning of hash table. Hash table in computing is a data structure, no, that implements an associative array abstract data type. Ito yung tinatawag na ADT. Okay? So, array is an ADT, also list and also queue, no? Or even stack. Those are example of ADT. These are structures that can map keys to values, no? For hash table, it uses the hash function, no, to compute for an index, and it is also called the hash code, no? So meron tayong mga terms dito. We have the map, no? Yung map meaning to assign. Okay, ina-assign niya, okay? Ina-assign ng structure yung keys to values. Okay? So yung keys na sinasabi dito, yung pagkakagamit ng keys ay ito yung index, no? So assigning the keys to the values and then using the hash function, okay, gives us a unique index for that value or for that key. So the underlying idea of hash table is very simple and quite appealing. Assume that given the key, there was a jumping straight to the entry for that key, then we would never have to search at all sequentially, no? So kasi pwede na tayong tumalon. We can jump, no, wherever we can find the values we are searching for. Now, assume that we have an array data to hold our entries, for example. Now we have a function h times k or hk that maps each key k to the index. So yung result ng hash function is an index, which is an integer. Okay? And yung key na sinasabi rito is the values, okay, which the hash function uses to produce these indices, no? So where the associated entry will be stored. Okay? So after computing the index, the values will be stored, no, in association with the resulting indices. Okay? So we have data h times k to find the entry with key k, no? So it would be easy if we could just make the data big enough to hold all the keys. For example, we have 0 to 99, then we could just create an array size of 100. Then store the entry key 67, for example, with data 67, no? So 67 represents the index number, and the data holds the value for the data 67. So it will result to the h as a function or the identity function of hk representing as k. This idea is not very practical when we are dealing with relatively small number of keys out of a huge collection of possible keys. So itong keys na ito magkaiba, no? Ito yung small number of keys ay pertains to the keys produced by the hash function, are used by the hash function, where the collection of possible keys represents the result, no? These are the values used by the hash function, and these are the result. For example, many American companies use their employees' 9-digit social security number as a key, even though they have nowhere near 109 employees, no? So kung meron kang 109 employees, yung 9-digit social security number na gagamitin mo as a key, hindi yun sapat, no? It is not enough to create indices for those 109 employees. So yun yung problem nun, no? If we will just use the key or the values as the key and put it as a hk function. We use the non-trivial function. Pag sinabing non-trivial, it's a more complicated, no, way of computing for the indices. So this is the so-called hash function represented by the letter H, that to map the space of possible keys to the set of indices of our array. Okay, so for example, we have 500 employees, then we create the 1000 entries or the size of the array and use the 3 digits from the social security number to produce the addresses or the indices. So this approach sounds like a good idea, but there is a pretty obvious problem with it, no? And it is called the collision. When 2 employees or more employees have the same 3 digits in based on our example, no, then it will produce collisions, no? So pag sinabing collisions, they have two different values have the same index number, no? So first of all, of course, one should try to avoid collisions. If the keys that are likely to actually occur are not evenly spread throughout the space of all possible keys, particular attention should be paid to choosing the hash functions H, no? So in this case, you should not choose the first 3 digits but the last 3 digits, or which digits are not more likely to produce, no, collisions when used as a hash functions. Okay, for example, if the first 3 digits represents the geographical location of each employees, then it would be more likely to produce collisions, no, than the last 3 digits which is not associated with any of their information. Okay, so we have a simple example of hash table operation. So we have an array size of 11. We will use a 3 character strings for the keys, and we'll choose from the range of character A to Z, no? So obviously the example is designed to illustrate the principle, no, of the typical real world hash tables, which is more bigger in size, no? We now have to define a hash function which maps each string, no, to an integer in the range of 0 to 10. Okay, so yung ating array merong 0 to 10, which represents the 11 size of that array, no? Because we start at 0 and end at 10, so it will give us a total of 11 slots. Okay, so let us consider one of the possibilities. First, we map string to a number as follows. Each character is mapped to an integer from 0 to 25, no? So this for this we have a 26 choices, no? 26 possibilities using its place in the alphabet A to Z, no? So A should have 0, B should be mapped to 1, so on and so forth until Z is mapped to value 25, no? For the 3 strings that we're going to use as a key, we have x1, x2, x3. Therefore, it will give us a number, any 3 number from 0 to 25, no? Say k1, k2, and k3. So the formula we will be using to map the string to the digits or the 3 digits, okay? Possible 3 digits and the possible strings from the letters of the alphabet would be this formula. Okay, so capture lang natin para lalo natin ma-explain. So k is equal to k1. So yung 26, no, squared represents the strings we coded as numbers in base 26. It is easy to go from any number k rather than the string, no? So we convert the string into digits using the base 26, no? So this represents any alphabet. Okay, so k1 times k1 is the any one of the strings multiplied by the first string, which is converted to a number. To convert this, we just simplify the exponents, no? So 26 to the 0 power is 1, so 1 times k3 is equal to k3, and 26 to the first power is also 26. So we will have the following conversion, okay? And we use this converted, no, strings to numbers to find the hash value. Okay, so we find the hash by using the modulus operation, which is the modulo 11. So why modulo 11? Because we have the 11 as the size of our array. If we have the size of a 100, then we can have the modulo 100, or 20. If we have an array size of 20, then we will use the modulo 20. Okay, but in this case we will use the modulo 11 because our example array has a size of 11 slots. Okay, so to get the h function or the hash function, we use this formula. Okay, so the modulo operation, this modulo operation and modular arithmetic more generally are widely used when constructing good hash functions. Okay, so we have our example here. So as a result of our hashing function, we can then list associated indices for each values in our array. Okay, so in order to locate the vacant or the empty slots, we use a pointer, which is a unique key. We can use a unique key or entry which is never associated with the record. So it will determine if the slots is still empty before we can put the corresponding data. So now we can begin inserting the case in order. So this is the result for the first three values. Now meron ditong mga example ng collision. We have the following collisions. Si 4, yan, they have the same index number, and these are called collision. These values should have a unique indices in order to be stored properly. Okay, so in order to solve that, we use the following method, which is the double hashing. It is a computer programming technique used in conjunction with open dressing in hash tables to resolve hash collisions. So paano yung technique na to? After the first hash functions, we use the resulting integer from the division of 11, apply the hash function, the second hash function to it in order to get the second hash key. And after getting the second hash key, apply it to the one of the collisions in order to eliminate the corresponding collisions. But there is a problem, which is it might give 0 at some point. So if this is the case, then an easy solution is to simply make the secondary hash function equal to 1, as shown in this example. So h2 meaning the second hash function. Okay, this is the representation of the double hashing. So n represents the number of data or number of slots we have. So k, the 11, and the second hashing. So if it's not equal to 0, then we will use that value, but if it's equal to 0, then we have, if otherwise, then we have to assign 1. So after getting the second hashing, applying the second hashing to HKG, then we have the result of 3. So we use, instead of 4, we use the index number 3 for HKG. Therefore, we have eliminated the first collision. Search complexity, the efficiency of double hashing is even more difficult than the linear probing. Pag sinabing linear probing, pinoprobe niya linearly yung slots inside the array. So dinedetermine lang niya kung alin pa yung next na vacant or empty space na pwedeng paglagyan nung isa sa mga nagkokos ng collisions. So yung sinasabing linear probing. So with load factor, yung load factor is the ratio of the symbolized or represented by the lambda symbol. Yung load factor na sinasabi, ratio nung number of records and with the number of available or possible key. A successful search requires 1 over the load factor. In comparison, on average, an unsuccessful one requires 1 over 1 minus the load factor. Note that it is a natural logarithm to base. So instead of base 2, okay, sometimes we will get the base 2.7. Okay? Thus, the hash table time complexity for search is again constant, represented by this complexity. Okay, how to choose good hashing functions. So first, we make sure a good hash function is to make sure that it spreads the space of possible keys or values onto the set of hash table indices as evenly as possible, no? So ibig sabihin, kung meron kang array na ganito, okay? So yung paglalagay mo ng mga keys or values should be even, no? For example, 1. So kung meron diyang dalawang space, 2, 3, then they are evenly distributed, no? Yun yung sinasabi. So they are less likely to produce collisions kung ganyan daw ang ating structure, no? When choosing secondary functions naman, hash functions, in order to avoid primary clustering, yun na nga, yung primary clustering is yung pang mga katabi, halimbawa 2, 3, tapos dito may 4, that is the what we call the clustering, no? One has to make sure that different keys with the same primary position give different results. And then simple remedy for the problem with secondary hash keys, okay, is to always make the size of the hash table a prime number. Okay, so that's the end for our finals lesson 1.